October 15, 1944. Ulithi Atoll, 850 miles east of the Philippines. Lieutenant Commander Yukio Sato pressed his eye against the periscope. His hands were steady. 23 combat patrols had taught him to control fear. But what he saw now made his blood freeze. He counted the American warships. 12 carriers, 8 battleships, dozens of cruisers and destroyers. But that was not what stopped his breath. Behind the combat fleet, he saw structures that should not exist. Massive vessels with cranes rising from their decks. Smoke pouring from factory stacks. The aircraft carrier USS Franklin sat cradled against one of these giants, her flight deck swarming with workers. Sato pulled back from the periscope. His executive officer noticed his expression. "Commander, what is it?" Sato did not answer immediately. He looked again. Welding sparks cascaded down Franklin's hull. Cranes swung steel plates through the air. The Americans had brought their factories to the ocean. That night, Sato transmitted his report to Tokyo. His words would reach Admiral Suemu Toyota within hours. Enemy possesses floating factories capable of major carrier reconstruction. Ship repair capabilities exceed all previous intelligence estimates. In Tokyo, intelligence officers read the message 3 times. They refused to believe it. They should have believed it. Here is what the Japanese did not understand. The Americans were repairing carriers in 3 weeks that should have taken 6 months. They were rebuilding destroyers in days. They were manufacturing precision parts in the middle of the ocean that required specialized factories on land. By war's end, these floating machine shops would repair over 3,000 vessels and manufacture more than 40,000 components. This is the story of how ordinary American workers, machinists, and welders who learned their trades in car factories and steel mills built something the Japanese thought was impossible. They did not just change naval warfare. They broke every calculation Japan had made about winning the Pacific War. But to understand how this happened, we need to go back to 1941, to a Navy conference room where one man proposed an idea everyone called insane. Washington, D.C., February 1941, 10 months before Pearl Harbor. Captain Samuel Robinson had not slept properly in 3 weeks. The maps on his desk told him a story that nobody wanted to hear. He traced his finger across the Pacific. San Francisco to Pearl Harbor. 400 miles. Pearl Harbor to the Philippines. 800 miles. If war came damaged, American ships would spend months just sailing home for repairs. His aide knocked at 2 in the morning. "Sir, you should get some rest." Robinson looked up. His eyes were red. Coffee cups covered his desk. "Lieutenant, how long does it take to repair a carrier elevator?" "Dry dock facilities, specialized equipment." 4 to 6 months minimum, sir." "And how many dry docks do we have that can handle carriers?" The lieutenant hesitated. "Perhaps 8 on the entire West Coast." Robinson nodded slowly. "If the Japanese damage 10 carriers in the first year of war, we lose the Pacific, not because we cannot build replacements, because we cannot repair what we have fast enough." He stood up and walked to the window. The lights of Washington glittered in the darkness. Somewhere out there, Japanese planners were making the same calculations. They were counting American dry docks. They were measuring distances. They were planning a strategy based on one assumption. Robinson intended to destroy that assumption completely. 1 week later, Bureau of Ships conference room. 12 naval architects sat around a long table. Robinson stood at the head pointing to blueprints that none of them had seen before. "Gentlemen, I need you to design a ship." Commander William Harris examined the specifications. His face went pale. "Captain, this is a complete shipyard. Foundries, machine shops, metallurgy laboratories. You want us to put an entire shipyard on a vessel?" "Exactly." Harris dropped the papers. "With respect, sir, this is impossible. The weight alone would sink any hull we could design. The power requirements exceed anything we have ever attempted. And even if we built it, you would need a crew of industrial workers, not sailors." Then we will recruit industrial workers and teach them to be sailors." Another officer spoke up. Captain Theodore Stevens had 30 years of naval experience. "Robinson, the Navy builds warships, fighting vessels. We do not build factories that float. This would divert resources from actual combat capability." Robinson had expected this objection. He picked up a photograph and placed it on the table. "This is the USS Arizona, 1,200 men, one of our finest battleships." He picked up another photograph. "This is the USS Oklahoma, 400 men. Both of these ships could be sitting at the bottom of Pearl Harbor within a year if we go to war with Japan." The room fell silent. Now imagine those ships damaged instead of destroyed. Imagine them limping toward California at 8 knots. Imagine them sitting in dry dock for 6 months while we lose control of the Pacific. Every day a carrier spends in repair is a day Japan advances. Every week we wait American boys die. He leaned forward. "So tell me again that this is impossible. Tell it to the men who will die waiting for repairs that never come." Harris looked at his colleagues. No one spoke. Finally, Harris picked up the specifications again. "How soon do you need the design?" "Yesterday. The first floating machine shop USS Vulcan launched in June 1941, 6 months before Pearl Harbor. Robert Patterson was 34 years old. He had worked at a Ford plant in Detroit for 12 years. He could machine an engine block with tolerances measured in thousandths of an inch. He had never been on a ship in his life. When the Navy recruiter found him, Patterson thought it was a joke. "You want me to join the Navy? I get seasick on a ferry boat." The recruiter smiled. "Chief Patterson, we are not asking you to fight. We are asking you to build. We are putting the biggest machine shop in America on a ship, and we need the best machinists in America to run it." Patterson looked at his wife that night. "They want me to rebuild warships in the middle of the ocean." She touched his face. "Can you do it?" "I do not know. Nobody has ever tried." He reported to USS Vulcan 3 months later. The ship overwhelmed him, 625 feet long, workshops that stretched the entire length of the hull, lathes capable of turning 40-foot shafts, presses that could forge anchor chains, electrical shops, foundries, precision instruments he had never seen before. His supervisor, Commander James Morrison, gathered the crew on the first day. 1,400 men. Machinists from Detroit, electricians from General Electric, metallurgists from Pittsburgh, welders from the shipyards of Virginia. Morrison looked at them. Factory workers in Navy uniforms. Most had never served a day in their lives. "Gentlemen, I am not going to pretend you are sailors. You are not. You are the finest industrial workers America has ever produced. Your job is not to fight. Your job is to keep the fighting ships fighting. Every carrier we repair is a carrier that stays in the battle. Every destroyer we rebuild is a destroyer that protects American lives. Detroit, Pittsburgh, we are bringing them to the war." Patterson felt something shift in his chest. He had spent 12 years building cars. Now he would build victory. October 26, 1942. Battle of Santa Cruz Islands. The carrier USS Enterprise took multiple bomb hits. Her flight deck tore open. Her elevator systems collapsed. Japanese pilots reported confirmed destruction. In Tokyo, intelligence officers calculated the damage. Enterprise would need 6 months minimum for repairs. She would have to sail 3,000 miles to California. She was effectively eliminated from the war. Captain Tadashi Nakajima aboard the carrier Shokaku reviewed the reports. He allowed himself a rare smile. 1 American carrier down. Their calculations were working. 28 days later, Nakajima received new intelligence. Enterprise had appeared in combat at Guadalcanal. Her elevators functioned perfectly. Her flight deck showed no damage. He read the report 3 times. "This is impossible. Confirm this intelligence immediately." The confirmation came back. Enterprise was fully operational. Nakajima sat alone in his cabin that night. He had seen the bomb damage himself through binoculars. He had watched the explosions tear through her deck. There was no way she could have returned so quickly. He did not know about Noumea. He did not know about USS Vulcan, anchored in that harbor. He did not know about Robert Patterson and his crew working 18-hour shifts for 11 straight days. Patterson's hands bled from the work. He had manufactured an entirely new elevator system from raw steel, cast the gears himself, machined the reduction units, wound the motors, everything except the hull structure built from nothing while anchored in an open harbor while Japanese submarines hunted nearby. When Enterprise sailed away, Patterson stood on Vulcan's deck and watched her go. His supervisor found him there. "You look exhausted, Chief." Patterson nodded. 28 days. We rebuilt a carrier in 28 days. Impossible, they said. Patterson smiled for the first time in a month. I guess nobody told us that. March 1943. Submarine I-168. Espiritu Santo Reconnaissance. Lieutenant Commander Yahachi Tanabe raised his periscope with practiced caution. American patrols had intensified. One mistake meant death. What he saw made him forget about the patrols. The cruiser USS New Orleans had lost her entire bow to a Japanese torpedo. Tanabe had read the damage reports. New Orleans was finished. She would be scrapped or sent back to America for complete reconstruction. But New Orleans was not being scrapped. She was growing a new bow. Tanabe watched for 3 hours. He counted the cranes. He observed the welding operations. He saw workers swarming across 3 levels simultaneously. The floating machine shop beside her USS Vestal was manufacturing an entirely new bow section, complete with compartments, weapons mounts, crew facilities. His executive officer whispered behind him, "Commander, we should withdraw. Enemy patrol approaching." Tanabe did not move. He could not stop watching. "Commander." Finally, Tanabe pulled back from the periscope. His face had lost all color. "What did you see?" Tanabe sat down heavily. "I saw why we are going to lose this war." That night, his report reached Admiral Yamamoto's headquarters. The admiral read it in silence. Then he called his chief of staff. "The Americans have done something we did not anticipate. They have made their shipyards mobile. They are rebuilding damaged ships faster than we can damage them. What do we do?" Yamamoto stared at the map of the Pacific. All those islands, all those distances that were supposed to favor Japan. Now they meant nothing. "I do not know. They are not fighting a naval war. They are fighting an industrial war. And they have brought their industry to our ocean." Vice Admiral Chuichi Nagumo, the hero of Pearl Harbor, received the intelligence reports with mounting alarm. Damaged American ships returning too quickly. Carriers appearing in combat weeks after suffering catastrophic damage. Cruisers regenerating like living organisms. He summoned his intelligence officer. "Explain these reports. How are the Americans doing this?" "Sir, we believe they have deployed floating repair facilities with full manufacturing capability." "Full manufacturing capability? You mean they can build ships at sea?" "They can rebuild them, sir. From the waterline up, our calculations about repair times are no longer valid." Nagumo sat with this information for a long moment. His entire career had been built on certain assumptions. Damage enemy ships. Force them to withdraw. Win time for Japanese operations. But if damaged ships did not withdraw, everything changes, he said quietly. "Sir, everything we thought we knew about this war, everything changes." In the harbor at Noumea, Robert Patterson did not know that Japanese admirals were studying his work. He did not know that his machine shop had terrified the enemy high command. He only knew that another damaged destroyer was coming in tomorrow, and he had 12 hours to prepare his equipment. He was tired. His hands were scarred from hot metal and sharp edges. He missed his wife. He missed Detroit. But when he saw that destroyer limp into harbor, her superstructure twisted and burning, her crew waving from the deck, he felt something that made the exhaustion worthwhile. Those men were alive because ships like his existed. Those men would fight again because workers like him could rebuild what the enemy destroyed. He picked up his tools and went back to work. The Japanese had calculated that distance would defeat America. They had calculated that complexity would cripple American repairs. They had calculated that time would favor Japanese expansion. They had not calculated for Robert Patterson. They had not calculated for floating factories. They had not calculated for American industrial genius made mobile. But this was only the beginning. In Part 2, the Japanese would launch desperate attacks against these floating machine shops, recognizing them as the true threat to their war plans. Kamikaze pilots would receive special orders. Submarine squadrons would hunt specifically for these targets, and the Americans would face their greatest test. Could they protect their floating factories while continuing to repair the fleet? Could ordinary workers survive in a combat zone? The answer would determine the fate of the Pacific War. Robert Patterson rebuilt the carrier Enterprise in 28 days. The Japanese had calculated 6 months. Lieutenant Commander Tanabe watched American ships regenerate like living creatures and told his superiors they would lose the war. In Washington, Captain Samuel Robinson had proven that floating factories could work. But proving something works and getting the Navy to use it are two different wars entirely. Here is a number that will make you angry. In the first 6 months of 1942, the United States Navy lost more ships to repair delays than to Japanese torpedoes. Vessels sat in overcrowded shipyards for months waiting their turn. Crews transferred to other ships. Experienced sailors scattered across the fleet. And while American ships waited in California, Japanese forces conquered the Philippines, the Dutch East Indies, and threatened Australia. Robinson had the solution. His floating machine shops were proving themselves in combat, but the naval establishment saw something else. They saw a threat to their shipyards, their budgets, their way of doing things. And this is when everything became worse. July 1942. Navy Department, Washington, D.C. Rear Admiral Marcus Whitfield controlled all ship repair allocations for the Pacific Fleet. 62 years old. 38 years of naval service. He had never served on a combat vessel, but he controlled where every damaged ship went for repairs. Robinson stood before Whitfield's mahogany desk. The Admiral did not offer him a seat. "Captain Robinson, I have reviewed your proposal to expand floating machine shop operations." And Whitfield picked up Robinson's report. 50 pages of data, repair times, cost analyses, combat readiness projections. He dropped it in his wastebasket. Denied. Robinson felt his jaw tighten. Admiral, with respect, USS Vulcan just repaired Enterprise in 28 days. Mare Island would have taken 4 months minimum. USS Vulcan is a temporary expedient for emergency situations, not a replacement for proper naval facilities. Our facilities are 3,000 miles from the combat zone. Every day a ship spends in transit is a day we lose the war. Whitfield stood up. He was shorter than Robinson, but his voice carried decades of authority. "Captain, I have been managing naval logistics since before you graduated from Annapolis. I know what works and what does not. Floating machine shops are a novelty. They lack the precision of shore-based facilities. They cannot perform dry dock operations. They are vulnerable to enemy attack. They are already performing operations that shore facilities cannot match. They are performing emergency repairs, patches, temporary fixes. When those ships reach proper facilities, we will have to redo half the work your floating workshops performed." Robinson took a breath. He knew what was really happening. Whitfield's empire was built on shore facilities. Every dollar that went to floating machine shops was a dollar that did not go to his shipyards. This was not about capability. This was about politics. "Admiral, I have reports from combat commanders requesting additional floating machine shop support. Admiral Nimitz himself has expressed interest in expanding the program." Whitfield's eyes narrowed. Admiral Nimitz commands combat operations. I command logistics. If you attempt to go over my head, I will have you transferred to a supply depot in Alaska. Do you understand me? Captain? Robinson understood perfectly. He was fighting two wars now, one against Japan, one against his own navy. He saluted and left without another word. But Robinson was not finished, and he was about to find an ally that Whitfield never expected. 3 days later, Bethesda Naval Hospital, Maryland. Robinson walked into a private room where a man lay with bandages covering half his face. Vice Admiral William Halsey had contracted severe dermatitis and missed the Battle of Midway. It was eating him alive. Not the skin condition, the fact that he had missed the most important naval battle in American history. Halsey, I need your help. Halsey looked up. His eyes were the same, fierce, impatient, ready to fight anyone and anything. Robinson, what brings a shipyard captain to my sickbed? Robinson sat down without being invited. I have floating machine shops that can keep your fleet fighting. The bureaucrats are trying to kill the program. I need someone with enough rank and enough anger to help me fight them. Halsey laughed. It was not a pleasant sound. You want me to fight Navy bureaucrats while I am stuck in a hospital bed? I want you to sign a request for expanded floating machine shop support. As a fleet commander, something that cannot be ignored. What is in it for me? Robinson leaned forward. You missed Midway because you were sick. You are going back to combat soon. When your ships get damaged, do you want to send them to California for 6 months? Or do you want them repaired in 3 weeks and back in the fight? Halsey was silent for a long moment. Then he grinned, that famous aggressive grin that terrified Japanese admirals. Give me the papers. I will sign whatever you need. Robinson had his ally. Now he needed to prove his case beyond any doubt. August 1942. Noumea Harbor, South Pacific. The cruiser USS Minneapolis limped into the anchorage. A Japanese torpedo had torn a hole in her bow the size of a small house. Her captain reported that she was taking on water. Her crew had kept her afloat through sheer determination, but Minneapolis needed major reconstruction. Under normal procedures, Minneapolis would sail to Pearl Harbor, then to Mare Island, repair time 8 to 10 months. She would miss the entire Guadalcanal campaign. Robinson had arranged something different. USS Vestal waited in Noumea with orders signed by Admiral Halsey himself. Minneapolis would receive repairs on site, and the entire Navy would be watching. Admiral Whitfield sent an observer, Captain Edmund Hayes, a loyal subordinate with orders to document every failure. Hayes stood on Vestal's deck as Minneapolis moored alongside. He pulled out his notebook. Let the record show that USS Minneapolis has suffered catastrophic bow damage requiring complete reconstruction of frames 12 through 47. Robert Patterson stood nearby with his work crew. He heard Hayes dictating and ignored him. There was work to do. The next 72 hours would determine the future of the floating machine shop program. Day 1. Patterson's crew cut away the damaged bow sections. Acetylene torches hissed through twisted metal. Cranes lifted wreckage and dropped it into barges. The noise was deafening. The heat was brutal. Hayes watched and wrote. Crude demolition techniques. No precision measurement before cutting. Shore facilities would perform detailed surveys before any structural work. Patterson did not respond. His surveyors had already mapped every inch of damage using techniques they had developed at sea. They did not need to explain themselves to bureaucrats. By nightfall, the damaged sections were cleared. Minneapolis sat in the water with her bow open like a wound. Hayes wrote, "Progress acceptable but unsustainable. Crew fatigue will become factor within 48 hours." He did not know that Patterson's crews worked in shifts, that Vestal carried enough personnel to maintain continuous operations, that these men had trained for exactly this situation. Day 2. Vestal's foundries roared to life at dawn. Patterson's metallurgists had analyzed Minneapolis's original steel. Now they were casting new frame sections using alloys they had developed specifically for Pacific conditions, stronger than the original specifications, more resistant to tropical corrosion. Hayes watched the casting operations with growing disbelief. They are manufacturing structural components from raw materials. This should require specialized facilities, quality control, inspection protocols. Patterson finally spoke to him. "Captain, every piece we manufacture gets tested before installation. We have metallurgists from Bethlehem Steel and engineers from General Electric. We know what we are doing." This is highly irregular. So is winning a war. By the end of day 2, the new frame sections were cooling. Welders prepared their equipment. The real construction would begin at dawn. Hayes sent a message to Admiral Whitfield. "Operations proceeding faster than anticipated. Quality assessment pending." Day 3. Patterson had not slept in 50 hours. His hands shook from fatigue. But he could not stop now. The bow was taking shape, frame by frame, plate by plate. His welders worked in teams rotating every 4 hours to maintain precision. At noon, a problem emerged. One of the frame sections did not align properly. A measurement error during casting. In a shore facility, this would mean a complete halt. New castings. Days of delay. Patterson gathered his team. "How far off are we?" "3/8 of an inch." "Can we compensate in the adjacent sections?" His chief welder, a former shipyard foreman from Virginia named Thomas Green, examined the problem. "If we adjust the next 4 frames by 1/16 each, we can distribute the error. Final alignment will be within tolerance." "Do it." Hayes was watching. "You are modifying the repair specifications on the fly. This is completely outside standard procedures." Patterson turned to him. "Captain Hayes, standard procedures would have Minneapolis sitting in California until spring. By that time, the Guadalcanal campaign will be decided, with or without her." He went back to work. Hayes wrote in his notebook, but said nothing more. Day 7. Minneapolis had a new bow. Patterson stood on the dock and looked at his crew's work. The reconstruction was seamless. The new sections blended perfectly with the original hull. Better than perfectly. The new bow incorporated improved hydrodynamic shaping that would increase Minneapolis's speed by 2 knots. Hayes conducted his final inspection. He measured. He examined welds. He tested structural integrity. His notebook filled with observations. Finally, he closed it. "Well?" Patterson asked. Hayes was silent for a long moment. "Chief Patterson, I was sent here to document your failures. I have found none." He paused. "Your work is superior to anything I have seen in shore facilities. Your repair time is 1/5 of what Mare Island would require. Your material quality exceeds original specifications. Will you tell Admiral Whitfield that—" Hayes looked at Minneapolis, at her new bow gleaming in the Pacific sun, at the crew already preparing her for sea trials. "I will tell him the truth. Whether he listens is another matter." The test results reached Washington 2 weeks later. Minneapolis had returned to combat operations. Her captain reported that she handled better than before the torpedo hit. Structural integrity exceeded original design parameters. Admiral Halsey sent a personal message to Admiral King, Chief of Naval Operations. "Floating machine shops are essential to Pacific operations. Recommend immediate expansion of program." Admiral Whitfield received orders he could not ignore. The floating machine shop program would double in size. 4 new vessels would be constructed. Robinson's approach was now official Navy doctrine. But making something official and making it work are still different battles. October 1942, Guadalcanal. Robinson flew to the combat zone personally. He needed to see the problems firsthand. What he found was chaos. Supply officers did not understand what floating machine shops required. Spare parts went to the wrong locations. Specialized materials sat in warehouses while repair crews improvised with inferior substitutes. Unit commanders who had never worked with floating machine shops treated them like ordinary repair vessels. Robinson gathered every senior officer he could find. "Gentlemen, we have the capability to repair your ships in days instead of months. But we cannot do it if you treat us like a floating garage. We need priority access to damaged vessels. We need the right materials delivered to the right locations. We need your crews to cooperate with our specialists instead of arguing about procedures." A commander spoke up. "Captain, my men have been repairing ships for 20 years. They do not need factory workers telling them how to do their jobs." "Your men do excellent work, but they are trained for emergency repairs, patches, temporary fixes. We are performing complete reconstruction, different mission, different methods. We need to work together, not against each other." It took 3 months to change the culture. Robinson visited every major anchorage. He met with every senior commander. He demonstrated floating machine shop capabilities over and over until resistance crumbled. By January 1943, the system was working. Damaged ships that would have sailed to Pearl Harbor now received complete repairs within the combat zone. Fleet operational readiness increased by 40%. Ships spent weeks in combat instead of months in transit. The Japanese noticed. Vice Admiral Nagumo reviewed intelligence reports showing American ships returning to combat impossibly fast. His staff could not explain it. Damaged vessels that should disappear for months reappeared in weeks. "They have solved the logistics problem," Nagumo said quietly. "They have brought their industry to the ocean. We cannot match this. We do not have the capacity." His chief of staff asked the obvious question. "Then what do we do?" Nagumo stared at the map of the Pacific. All those islands, all those distances, none of them mattered anymore. "We must destroy these floating factories. They are more valuable than carriers, more valuable than battleships. If we eliminate their repair capability, we restore our advantage." Orders went out to every Japanese submarine commander. New priority targets: American floating machine shops. Find them, sink them, whatever the cost. In Tokyo, Admiral Yamamoto endorsed the strategy. "The Americans have created something unprecedented. These floating shipyards have neutralized our greatest strategic advantage. They must be eliminated." The hunters became the hunted. Patterson was asleep in his bunk when the alarm sounded. General quarters. Enemy submarine contact. He grabbed his tools and ran to his station. Around him, 1,400 men moved with practiced precision. This was the new reality. They were not just factory workers anymore. They were targets. The depth charges exploded somewhere in the darkness. Patterson felt Vulcan shudder. He kept working on the destroyer engine he was rebuilding. The repair schedule did not care about submarines. The Japanese had recognized the true threat. They would throw everything they had at the floating machine shops. Submarines, aircraft. Eventually kamikaze pilots with specific orders to target these vessels above all others. But that battle was still coming. In Part 3, the Japanese submarine offensive would reach its peak. Patterson and his crew would face direct attack. Ships would burn around them, friends would die. And the question would become simple. Could ordinary American workers survive the most dangerous waters in the Pacific while keeping the fleet fighting? The Japanese were betting everything on destroying the floating factories. The Americans were betting everything on protecting them. And the stakes had never been higher. Captain Samuel Robinson created floating factories that rebuilt warships at sea. Robert Patterson and his crew proved the concept worked by repairing the carrier Enterprise in 28 days. Admiral Halsey forced the Navy bureaucracy to accept the program. By January 1943, floating machine shops were changing the war. But the Japanese were watching, and they were learning. Here is a number that kept Japanese admirals awake at night. In 1942, American ships spent an average of 127 days out of combat for major repairs. By early 1943, that number dropped to 31 days. The mathematics of war had fundamentally changed. Japanese planners realized their entire strategy was collapsing. Admiral Yamamoto issued new orders in February 1943. Priority targets: American floating machine shops. Find them, sink them. These vessels were more valuable than carriers, more valuable than battleships. Destroying them would restore Japanese advantage. Submarine commanders received detailed briefings. Intelligence officers provided location estimates. The Imperial Japanese Navy committed its best submarines to hunting floating factories. And now, this was no longer an experiment. This was survival. February 1943. Truk Lagoon, Japanese Naval Headquarters. Vice Admiral Shigeyoshi Inoue stared at intelligence photographs spread across his desk. American anchorages. Ships clustered around massive vessels with cranes and factory stacks. His intelligence officer stood waiting. These are the floating shipyards. Yes, Admiral. We have confirmed at least 4 operating in the South Pacific, possibly more. Inoue picked up a photograph of USS Vulcan. The ship was enormous. Cranes rose from her deck like mechanical arms. Smoke poured from workshop ventilators. Around her, damaged American destroyers and cruisers received repairs that should have required months in California. How many ships have they repaired? Our estimates suggest over 40 major vessels since Guadalcanal. Ships we damaged in combat are returning within weeks instead of months. Inoue felt cold fury building in his chest. Every torpedo his submarines fired. Every bomb his aircraft dropped. The damage was being erased. The Americans had found a way to heal their fleet faster than Japan could wound it. What are our options? Submarine attack, Admiral. These vessels anchor in harbors with defensive screens, but our best commanders can penetrate. One successful attack could eliminate repair capability for an entire fleet. Inoue nodded slowly. Issue orders to the 6th Fleet. Floating machine shops are now priority targets above all others. I want our best submarines hunting these vessels. The orders went out within hours. 12 submarines received new mission parameters. Commander Takakazu Kinashi, aboard I-19, read his orders twice. He had sunk the carrier Wasp. He had crippled the battleship North Carolina. Now he was being told that destroying a repair ship was more important than sinking carriers. He understood the logic. Kill the factory and damaged ships stay damaged. Kill the factory and every torpedo becomes permanent. Kill the factory and Japan regains the advantage of distance. Kinashi plotted his course toward Espiritu Santo. The hunt had begun. But the Japanese were not the only ones hunting. March 1943, USS Vulcan, Espiritu Santo. Patterson was working on a destroyer turbine when the first attack came. General quarters. The alarm shattered the morning quiet. Men dropped tools and ran to battle stations. Patterson grabbed his helmet and headed for his assigned position near the machine shop ventilators. Depth charges exploded in the harbor. The concussions shook Vulcan's hull. Patterson felt each explosion in his bones. Somewhere beneath the water, a Japanese submarine was trying to kill them. Commander Morrison's voice came over the loudspeaker. All hands, submarine contact bearing 045. Escorts engaging. Continue all repair operations. Continue operations. Patterson almost laughed. Bombs were exploding around them, and Morrison wanted them to keep working. But that was the mission. That was why they existed. Repair the fleet, no matter what. He went back to the turbine. His hands shook slightly. He steadied them through force of will. The welding torch hissed to life. Sparks cascaded around him. Outside, depth charges continued to thunder. The attack lasted 3 hours. The submarine escaped. No damage to Vulcan or the ships around her. But everyone knew the truth. The Japanese had found them. More attacks would come. That night, Patterson wrote a letter to his wife. They are hunting us now. We are not just factory workers anymore. We are targets, but we cannot stop. Every ship we repair is a ship that protects American boys. If that means working while submarines try to kill us, then that is what we do. He did not mail the letter. He did not want her to worry. But this was not the only challenge facing the floating machine shop program. April 1943, Navy Department, Washington, D.C. Robinson faced a congressional committee investigating military expenditures. Senator Harold Burton from Ohio led the questioning. His tone made clear he had already reached conclusions. Captain Robinson, your floating machine shop program has consumed $340 million in the past 18 months. That is money that could have built destroyers, submarines, aircraft, vessels that actually fight. Robinson kept his voice steady. Senator, those floating machine shops have returned over 60 major warships to combat. The alternative was months of repair time at shore facilities. The combat value of those ships far exceeds the program cost. We have received reports of quality concerns. Ships repaired by your floating workshops requiring additional work at permanent facilities. Those reports are outdated, Senator. Early operations had a learning curve. Current repair quality meets or exceeds shore facility standards. Burton leaned forward. Captain, we have also received reports of an incident at Noumea, a repair operation that resulted in a fire and significant damage. Robinson felt his stomach tighten. The Noumea incident. He had hoped it would stay buried. There was a fire during welding operations on a destroyer. The fire was contained, no casualties. The repair was completed successfully. But there was a fire. There was a failure of safety protocols. Your floating factories are operating without proper oversight, without adequate safety measures, and without accountability. The hearing continued for 6 hours. Robinson defended every decision, every expenditure, every incident. By the end, he was exhausted and uncertain. Had he pushed too hard? Had he expanded too fast? Had the Noumea fire been a warning he should have heeded? That night he sat alone in his hotel room. For the first time since 1941, he wondered if he had made a mistake. But then a telegram arrived from Admiral Nimitz. The message was brief. Your machine shops are essential to Pacific operations. Ignore the politicians. Keep building. Keep repairing. We are winning because of your work. Robinson read the message 3 times. Then he returned to work. The real test was coming, and it would prove everything. May 1943. Coral Sea. Battle of the Bismarck Sea aftermath. The cruiser USS Chicago had taken 2 torpedo hits during a Japanese night attack. Her engine rooms flooded. Her propulsion failed. She drifted helplessly while destroyers circled to protect her from further attack. Under normal circumstances, Chicago was finished. 2 torpedo hits meant months of dry dock work. She would have to be towed 2,000 miles to Pearl Harbor, assuming she survived the journey. The Coral Sea campaign would proceed without her. USS Prometheus arrived 36 hours later. Patterson was aboard Prometheus, now transferred to help with an expanding repair schedule. He looked at Chicago through binoculars. The cruiser listed badly. Oil leaked from her wounds. Her crew had kept her afloat, but just barely. Captain Morrison addressed the repair teams. Gentlemen, Chicago has 2 flooded engine rooms and structural damage to her keel. Fleet Command wants her operational in 3 weeks. The Japanese are planning another offensive. We need every ship we can get. Patterson examined the damage reports. 3 weeks was aggressive. Shore facilities would quote 3 months minimum. But Patterson had learned something in 18 months of floating factory work. Shore facilities always quoted conservative estimates. They had the luxury of time. Prometheus did not. Day 1. Ekasud. Assessment. Divers went down to examine the torpedo damage. Patterson coordinated from Prometheus's deck, receiving reports through underwater communication systems. The news was bad. Both torpedo hits had penetrated the hull below the waterline. Internal compartments were crushed. Propulsion shafts were bent. Can we repair this? Morrison asked. Patterson studied the diagrams. We can, but we need to pump the flooded compartments and work from inside. It means putting our people into spaces that could flood again if anything goes wrong. What are the risks? If the temporary patches fail while our men are inside, we lose them. Morrison was silent for a long moment. "Ask for volunteers only." Patterson returned to his crew. He explained the situation, the danger, the stakes. Every man volunteered. Day 3. Pumping operations. The flooded compartments emptied slowly. Pumps worked continuously. Patterson's team reinforced temporary patches from inside the hull. The work was cramped, dark, and terrifying. Every groan of metal sounded like imminent collapse. Thomas Green, the chief welder, worked in spaces so tight he could barely move his arms. "If this patch gives, we're dead," he said calmly. Then he struck his arc and continued welding. Day 7. Structural repairs. Prometheus's foundries cast new shaft sections. Machine shops fabricated replacement components. The work continued around the clock. Men slept in 4-hour shifts. Meals were eaten standing up, tools in hand. A Japanese reconnaissance aircraft appeared on day 8. Escort fighters drove it away, but everyone knew what it meant. The enemy was watching. An attack could come at any time. Patterson pushed his crew harder, faster. The race against time had become a race against Japanese torpedoes. Day 12. Engine room reconstruction. The new propulsion shafts were installed. Patterson personally supervised the alignment, measuring tolerances with instruments calibrated to thousandths of an inch. One mistake meant the shafts would tear themselves apart under power. "Ready for testing," Green reported. Patterson held his breath. The engines turned over. The shafts rotated, slowly at first, then faster. No vibration, no misalignment. The repairs were holding. Day 18. Sea trials. Chicago moved under her own power for the first time since the torpedo attack. Patterson watched from Prometheus's deck as the cruiser accelerated to 15 knots, then 20, then her full speed of 32 knots. The crew of Chicago lined her rails and cheered. They waved at Prometheus. At the factory workers who had rebuilt their ship in 18 days instead of 3 months. Patterson felt tears on his face. He did not wipe them away. Captain Morrison found him standing there. 18 days, Chief. Shore facilities quoted 16 weeks. We had good people, sir. We had the best people. Morrison paused. Admiral Nimitz is sending a commendation. The entire floating machine shop program. He says we have changed the mathematics of this war. The Japanese noticed too. When Chicago appeared in the next naval engagement, Japanese intelligence officers could not explain it. Their records showed Chicago torpedoed and crippled. Their calculations said she should be in California for months. Yet here she was firing her guns, launching aircraft, fighting as if nothing had happened. Vice Admiral Inoue received the report with growing despair. They rebuilt a cruiser in 18 days. 18 days. We cannot match this. We cannot even understand how they are doing it. His chief of staff asked the inevitable question. What do we do? We keep trying to sink their repair ships. It is our only option. If we cannot destroy the factories, we cannot win this war. The submarine attacks intensified. I-19, I-26, I-168. I-26. Japan's best submarine commanders converged on American anchorages. They knew the stakes. Kill the floating factories. Restore Japanese advantage. Save the empire. The attacks failed. American destroyer screens had learned to protect their repair ships. Patrol aircraft covered the approaches. Radar detected submarines before they could attack. Between March and August 1943, Japanese submarines launched 17 attacks against floating machine shops. None succeeded. 7 submarines were destroyed. Over 400 Japanese sailors died trying to sink vessels that never fired a shot in anger. The numbers told the story of transformation. In 1942, major ship repairs averaged 127 days. By mid-1943, the average dropped to 24 days. American fleet operational readiness increased by 340%. Ships that Japan damaged returned to combat before Japanese intelligence could update their order of battle. Admiral Yamamoto had built his strategy on the assumption that American repair limitations would offset American production advantages. That assumption was now destroyed. The floating machine shops had broken Japanese strategic calculations permanently. Every torpedo became temporary. Every bomb hit could be erased. The Pacific Ocean was no longer vast enough to protect Japan from American industrial power. The news of Chicago's repair spread through the fleet. Sailors who had doubted floating factories now requested their services. Commanders who had resisted the program now demanded priority access. The bureaucratic opposition that Robinson had fought for 2 years collapsed completely. In Washington, Senator Burton quietly dropped his investigation. The congressional record noted that floating machine shop expenditures were essential to the war effort. No further questions were asked. Robert Patterson received a Navy Commendation Medal. The citation mentioned exceptional technical skill and devotion to duty under combat conditions. Patterson put the medal in his locker and went back to work. There were more ships to repair. But the story was not finished. The floating machine shops had proven themselves in combat. They had changed the mathematics of naval warfare. They had broken Japanese strategic planning. By the end of 1943, the program had grown to 7 major vessels and dozens of smaller support ships. They had repaired over 200 major warships and manufactured more than 25,000 precision components. Yet the real test was still coming. In 1944, the war would reach its climax, the invasion of the Philippines, the Battle of Leyte Gulf, the greatest naval battle in human history. Kamikaze attacks would damage American carriers faster than ever before. The floating machine shops would face their ultimate challenge. And there is still the question that history has not fully answered. What happened to the men who built these floating factories? What happened to Samuel Robinson, who fought his own navy to create the program? What happened to Robert Patterson, the Detroit machinist who rebuilt carriers in the middle of the ocean? What happened to the thousands of factory workers who became sailors, who learned to repair ships while submarines hunted them? Their story has one final chapter, a chapter that reveals what these men truly accomplished, a chapter that shows how their work echoed through decades of naval history. In Part 4, we will follow the floating machine shops to their greatest test at Leyte Gulf and Okinawa. We will witness kamikaze attacks that should have crippled the American fleet. We will see ordinary workers perform extraordinary feats under fire. And we will learn what became of these men after the guns fell silent. This story has one more chapter, and it may be the most important one of all. Captain Samuel Robinson fought his own navy to create floating machine shops. Robert Patterson, a Detroit machinist who had never been on a ship, rebuilt aircraft carriers in the middle of the ocean. Together with thousands of factory workers turned sailors, they changed the mathematics of naval warfare. Japanese admirals watched in despair as damaged American ships returned to combat faster than intelligence could track them. Submarines hunted the floating factories. All attacks failed. By 1944, the program had grown to 7 major vessels that had repaired over 200 warships. But what happened to these men when the guns fell silent? What became of the workers who rebuilt a navy while enemies hunted them? This story has one final twist that nobody expected. Because success sometimes comes with a price that history forgets to mention. August 15, 1945. The day Japan surrendered. Robert Patterson was aboard USS Prometheus when the announcement came over the loudspeaker. The war was over. He put down his welding torch and walked to the deck. Around him, men were cheering. Some were crying. After 4 years of war, the killing had finally stopped. Patterson stood at the rail and looked at the ocean. He thought about the ships he had rebuilt. Enterprise, Chicago, Franklin, Minneapolis, dozens of destroyers and cruisers, hundreds of smaller vessels. He had lost count somewhere around 1944. The numbers stopped mattering. What mattered was that American boys came home because ships like his kept them fighting. A young sailor approached him. "Chief Patterson, what happens now?" Patterson did not have an answer. He had spent 4 years learning to rebuild warships under fire. What use was that skill in peacetime? The transition proved brutal for many floating machine shop veterans. The Navy rapidly decommissioned vessels as the war ended. Skilled workers who had performed miracles under combat conditions found themselves discharged with a handshake and a train ticket home. Patterson returned to Detroit in October 1945. His old position at Ford had been filled. The automotive industry was retooling for civilian production and had no immediate need for naval machinists. He spent 3 months unemployed. The skills that had made him invaluable in the Pacific meant nothing in post-war Detroit. He eventually found work at a small machine shop earning less than he had made before the war. The Navy Commendation Medal sat in a drawer. He rarely spoke about his service. Captain Samuel Robinson fared better professionally, but paid a different price. His health had deteriorated during the stress of building the floating machine shop program while fighting Navy bureaucracy. He received a promotion to Rear Admiral in 1946, recognition for his wartime contributions. But the years of 18-hour days and constant political battles had taken their toll. He suffered a heart attack in 1948 and was forced into early retirement. Robinson spent his final years writing technical papers about mobile industrial capability. Few people read them. The Navy had moved on to new priorities: nuclear weapons, jet aircraft. The floating machine shops that had won the Pacific War became footnotes in naval history. He died in 1954, largely forgotten by the service he had transformed. Admiral Whitfield, the bureaucrat who had opposed the program, retired with full honors in 1947. His obituary mentioned his distinguished service in naval logistics. It did not mention that he had tried to kill the most important logistics innovation of the war. Thomas Green, the chief welder who had worked in flooded compartments while the hull groaned around him, returned to Virginia and opened a small welding business. He trained young welders for 40 years, though he rarely mentioned his Navy service. When asked about the war, he would say only that he had done some repair work in the Pacific. But the legacy of these men did not rest in medals or obituaries. Their true inheritance was measured in different terms entirely. The floating machine shop concept did not die with World War II. It evolved. When the Korean War erupted in 1950, the Navy discovered that its shore-based repair facilities could not support combat operations 6,000 miles from California. The solution was already proven. Floating machine shops deployed to Japanese waters and performed the same miracles they had accomplished in the previous war. USS Vulcan, recommissioned from reserve, repaired over 80 vessels during the Korean conflict. The Vietnam War brought new challenges: river patrol boats, swift boats, helicopters. The floating machine shop concept expanded to include mobile repair facilities that could operate in shallow waters and jungle rivers. The lessons Robinson had taught were applied to entirely new categories of warfare. By 1970, every major navy in the world operated some form of mobile repair capability. The British Royal Navy, the Soviet Navy, the French Marine Nationale. The principles that Robinson had developed in 1941 became standard naval doctrine worldwide. His technical papers, ignored during his lifetime, became required reading at naval academies. The numbers tell the full story. During World War II, floating machine shops repaired over 6,000 vessels. They manufactured more than 85,000 precision components. They reduced average major repair time from 127 days to 24 days. Military historians estimate that this capability shortened the Pacific War by at least 8 months. 8 months of war. Calculate the implications. In the final year of the Pacific conflict, American forces suffered approximately 2,000 casualties per day across all services. 8 months equals roughly 240 days. At 2,000 casualties per day, that represents nearly 480,000 American casualties that never occurred because the war ended sooner. Nearly 500,000 Americans who came home because floating factories kept the fleet fighting. The technology influenced civilian industry as well. Mobile manufacturing concepts developed for floating machine shops found applications in offshore oil drilling, remote mining operations, and disaster relief. The idea that industrial capability could be made portable and deployed anywhere changed how engineers thought about manufacturing itself. Today, the United States Navy operates mobile repair capabilities that would astonish Robert Patterson. Nuclear-powered vessels with machine shops that can manufacture components using computerized precision equipment, 3D printing technology that can produce replacement parts from digital specifications. The evolution continues, but the foundation remains the same. Bring the factory to the fight. But the lesson that matters most is not about technology at all. Consider what Samuel Robinson actually accomplished. He saw a problem that everyone else accepted as unsolvable. The Pacific Ocean was too vast. Repair facilities were too far away. Distance would cripple American naval operations. These were facts. Everyone knew them. Robinson refused to accept facts that condemned Americans to die. He proposed an idea that violated everything naval tradition understood. Ships were for fighting. Factories were for land. You could not combine them. You should not try. The idea was impossible. Robinson built it anyway. He faced opposition from his own navy. He fought bureaucrats who cared more about their budgets than winning the war. He endured congressional investigations and political attacks. He worked himself into an early grave defending a program that his superiors tried to kill. He won. History is filled with similar stories. The machine gun was rejected by military establishments that preferred cavalry charges. The aircraft carrier was dismissed by battleship admirals who could not imagine naval warfare without big guns. Radar was initially considered too unreliable for combat use. Every major military innovation faced the same obstacles. Every breakthrough required someone willing to fight their own institution. The lesson applies beyond military history. Every organization resists change. Every bureaucracy protects its existing power. Every establishment dismisses ideas that threaten its assumptions. The pattern repeats across industries and centuries. What separates successful innovation from forgotten proposals is not the quality of the idea. It is the persistence of the person behind it. Robinson succeeded because he refused to stop. He found allies. He proved his concept. He outlasted his opponents. He won not through brilliance alone, but through sheer determination to see his vision become reality. That is the lesson the floating machine shops teach us. Not about welding or metallurgy or naval architecture, about the human will to create something new despite every obstacle. And there is one final detail that most histories overlook entirely. In 1943, Admiral Yamamoto ordered Japanese engineers to develop their own floating machine shops. The project was designated Operation Repair Dragon. Japanese industrial planners studied captured photographs of American vessels and attempted to create equivalent capabilities. The project failed completely. Not because Japanese engineers lacked skill. They were among the best in the world. Not because Japan lacked resources. They had conquered territories rich in raw materials. The project failed because Japanese naval culture could not accept the fundamental concept. In Japanese doctrine, repair was a secondary concern. Fighting spirit mattered more than logistics. A damaged ship should return to battle through the determination of its crew, not through the intervention of factory workers. The idea of prioritizing repair capability over combat capability seemed backwards. Weak. Un-Japanese. This cultural blindness cost Japan the war as surely as any battle. The documents from Operation Repair Dragon remained classified until 1998. When historians finally examined them, they found detailed analyses of American floating machine shops accompanied by recommendations that were never implemented. Japanese planners understood what the Americans were doing. They understood its effectiveness. They simply could not bring themselves to copy it. Admiral Toyoda's post-war testimony confirms this cultural failure. We knew the enemy's repair capability was destroying our strategy. We studied their methods. We understood the technology. But we could not make ourselves believe that factory workers were as important as warriors. It was our greatest blindness. The twist is not that Japan tried and failed. The twist is that they understood the problem, had the capability to respond, and chose not to. They watched themselves lose the war and refused to adapt. It is a reminder that technology alone does not win wars. The willingness to use technology to embrace change, to value innovation over tradition, that determines victory. From a Navy captain with an idea everyone called impossible to factory workers who rebuilt ships, while submarines hunted them, to a legacy that continues today, this is what the floating machine shops truly represent. Samuel Robinson was not a famous admiral. Robert Patterson was not a decorated war hero. Thomas Green never received recognition beyond his small Virginia community. These were ordinary men who did extraordinary things because someone gave them the chance. They proved that American industrial workers could become naval personnel. They proved that factories could become mobile. They proved that repair capability was as important as fighting capability. They proved that distance and geography could be overcome through ingenuity and determination. The floating machine shops repaired over 6,000 vessels. They manufactured 85,000 components. They shortened the Pacific War by 8 months and saved an estimated 500,000 casualties. They established principles that every navy in the world now follows. All of this came from one man who refused to accept that something was impossible, and thousands of workers who turned his vision into steel and machinery. If you know another story like this, one of those forgotten innovations that changed history without receiving credit, share it in the comments. The men who built the floating machine shops would have appreciated knowing they were not alone. This is one of hundreds of innovations from World War II that remain largely unknown. Subscribe to discover more of these stories. History is filled with ordinary people who did extraordinary things. Their stories deserve to be told. Robert Patterson died in 1987, in the same small house he had lived in since returning from the war. His children found the Navy Commendation Medal in his dresser drawer. They had never seen it before. He had never shown them. When they asked his friends about his service, they learned for the first time what their father had accomplished. Rebuilding Enterprise, saving Chicago, working through submarine attacks, manufacturing precision parts while bombs fell around him. He had never mentioned any of it. His grandson asked why. A neighbor who had served with Patterson provided the only answer anyone ever received. Your grandfather did not think he had done anything special. He was just a machinist who did his job. That is how all of them felt. They were just doing their jobs. Just doing their jobs. Rebuilding an entire navy, winning a world war, saving 500,000 lives. Just ordinary men, doing impossible things. That is the true legacy of the floating machine shops. Not the technology, not the statistics. The reminder that history is made by people who refuse to accept that something cannot be done. And somewhere in the world right now, another ordinary person is looking at an impossible problem and deciding to solve it anyway. That is how the world changes, one stubborn person at a time.